All right, so we're going to do the exponential and logarithmic equations. So solving the equations. The thing with these is, here's your pep talk. There's a bunch of different ways you can approach them, and that's why I have a space there, methods for solving these. I'm going to show you one method. We'll do a couple problems. I'll show you another one. We'll do a couple problems. What I always get asked is, Ms. Cole, how do I know what method to use? And here's the true answer. You kind of just have to look at the problem and see what you can do. And I realize like that's a totally crap answer, but I don't have a better one. You kind of just need to look at the problem and go, hey, how could I approach this? So I'm gonna give you like some tools for your toolbox, and then you sort of need to look at it and figure it out, okay? So for solving, we're gonna do the exponential ones on this side, the logarithmic ones on this side. So for the exponential ones, first kind of method here, same base means same exponents. So if you can get the base number to be the same, essentially they'll cancel out. You can just set the exponents equal to each other. So you kind of want to look at what you've got and say, hey, can I make the bases the same? Now I have these problems in order for how we're going to go through these. That's what we're going to look at for questions 1 and 2. So look at question 1. You just have to be a good noticer. Do you see how that's an 8 and that's a 4? Coming with me on this? What base could you make both of these? Like you want to come up with a small number that you could raise to a power and get 8 and get 4. 2, let the math instinct kind of kick in, like does 2 seem like it would make sense? All right, I can make it be 2 on both sides. 2 to what power is going to give you 8? Third, good. So 2 to the third would be 8. And then I've still got that 3x minus 1 that's like that part's just there. Like it's just there. And then on the right side, I want that to also be 2. 2 to what power would give you 4? Second, good. 2 to the second. And then that x plus 2 is kind of just there. So do you see how we made it both 2 on each side? Those are going to drop out and you can just set the exponents equal to each other. That was kind of the whole point, right? So we're going to set this equal to this. We're going to need to distribute. So distribute the 3 over here. That'll give you 9x minus 3 equals, and then distribute the 2 over here. That'll be 2x plus 4. Subtract the 2x, you'll have 7x minus 3 equals 4. Like we're down to an algebra 1 kind of problem here. Add 3. Divide by 7, we get x equals 1. So if you look at it and you go, hey, I can make the base the same on both sides, then try that approach. So look at number 2. Do you see how this is a 4 and this is a 1/16? Coming with me on that? I can make the base 4 for both of those, which is really nice because that means this one doesn't have to change. I can just leave this all the same. No work is great. We love no work. So that's fantastic. Because I usually get, hey, can't you make them both 2? That's true. But if you can make it 4, you don't have to mess with this side of it. So that's good. All right, so over here, I want it to be 4. So here's the question. 4 to what power will give you 1/16? Good, nice job, -2. So we made them both 4. That means those are gonna cancel out. They drop out because it's the same. Just set the exponents equal to each other. Oops. Now this one has a squared in it, so how would we handle that? Yeah, good, add the 2 over, evacuate. Make it all equal 0, and then you can factor. So we're gonna get 2 answers for this one. So it'll be x and x, 1 and 2, and then what symbols will we need in there? Both minus, perfect. So setting those equal to 0, we'll get x equals 1 and x equals 2. So if you look at it and it seems like you could turn both of the bases into the same number, then you would want to try that, right? If that's not going to work, you can use a logarithm, right? Logs and exponentials are inverses, so they can cancel out. So log with the correct base. That will cancel out with the exponential. Logarithms and exponentials are inverses. They can undo each other. So we're going to do a few like that. So look at number 3. At first glance, you can't make both the bases the same because you have a 7, like 2 to what power gives you 7? Anybody? You know what I mean? Like it's not going to work. So what we would do to both sides is log base 2. You're going to log base 2 both sides because that will cancel out with the exponential base 2. The log base 2 and the exponential base 2 cancel. You would just get x equals log base 2 of 7. Here's where the calculator comes in. We want to type in log base 2 of 7. Don't hit this button right here. Do you see this button that says log? The reason we don't want that is if it's just log log, what base is that? That's 10, and we want base 2. Okay, so don't use that. Instead, go to the math menu. Here's your math button. It's right below alpha. Hit math. Scroll down until you get log base. It's actually faster if you scroll up because it's so close to the bottom of the list. But do you guys see log base in there? Choose that, and then you can type it in. Log base 2 of 7. Did you get this? 2.807354, blah, blah, blah. Okay, you need to do 3 decimal points. I know not everybody will go on to AP Calc, but enough of you will. And I have to teach you all, like I have to grade everything consistently. Do the first 3 decimal points. It's the first 3 that you see, just do that. 2.807. Let's try that again. If you're like, hey, I didn't quite get that, well, let's try it again. Look at the next one. Do you see how this is 4 and that's 17? I can't make them both the same base. There's no way to do that. So we are going to log base 4 both sides because that will cancel out with the exponential base 4. So you're going to log base 4 both sides. So those cancel. That'll give you 1/3 x equals log base 4 of 17. And then what would be your last step to get x by itself? How do you cancel out a 1/3? Multiply by 3. So it will be 3 log base 4 of 17. And then that's where the calculator comes in. That's what we're going to type, okay? So you're going to do 3 and then go to the math menu and get log base. And it was log base 4 of 17. Please make sure you type with me. Don't be like, oh, I'll just watch her do that. Typing it is a skill that you're going to need on your test. Okay, you're going to have to be able to get it. Anyone feeling brave? What did you get? Me too, 6.131, awesome. All right, let's try another one. Here, you would divide over the 75. So divide both sides by 75. I can't remember if that comes out nice or not. Oh, it does, 3. So 2 to the power 3x equals 3. I divided over the 75. Okay, what log base are we going to do to both sides? 2. See how there's a 2 there? Do log base 2 to both sides, and it will cancel that out. So you get 3x equals log base 2 of 3. And then what would be your last step? You want x alone. Yep. Divide by 3. So this is what you're going to type in the calculator. Log base 2 of 3 divided by 3. Everybody go ahead and try it, and then we'll share what we got. Is anyone feeling brave? Want to share what decimal you got? What'd you get? 0.528? Me too. 0.528. All right, let's try one more like this. How would I move over the 7? Divide, good, divide by 7. So e to the 5x equals 2/7. Ooh, what log are we gonna do to both sides this time? How do we cancel out e? ln both sides, perfect. So ln and e cancel, you get 5x equals ln of 2/7. And then divide by 5. So that's what you're going to type into your calculator, ln of 2/7 divided by 5. And if you want to put parentheses around the 2/7, the calculator will start a parenthesis for you anyway. But that's where the parentheses would go. You're ln'ing the 2/7 and then dividing by 5. Oh, so do you guys remember where your ln button is? Right here, kind of next to the 4. All right, who's feeling brave? What'd you get? Everyone's like, nah, I'm not confident. Did you get negative 0.250? Okay, now you're like, okay, I'll tell her I got that. All right, negative 0.250. All right, looking at this, that kind of looks like a mess, and I get that that looks scary. So here's another method that you have. Use your exponent rules. I keep harping on about them, and everyone's like, oh, I'll remember them on another day. Care now. Everyone only cares once the test is in front of them, and then all of a sudden it's like, wow, I really wish I had this. Care now, okay? Exponent rules. When you multiply, what do you do to your exponents? Good. When you divide, subtract, a power to a power, multiply. Okay, so look at number 7. Do you see how that's being divided? That means we're going to subtract the exponents. So subtract them. 3x minus 1x is 2x. You get e to the 2x equals 4. Oh, now it's a lot like the problem we just finished. What would you do to both sides? ln, good. ln both sides. ln and e cancel. You'll have 2x equals ln of 4. And then divide by 2. Yes, ma'am. Right, so whenever you're dividing, you subtract the exponents. So we subtracted these. So 3x minus 1x, we got 2x. So like, for example, let me make so hey, everybody, say it looked like this. What would that give you? Yeah, you would just subtract them. All right, so everyone type this in your calculator. ln of 4 over 2. And the calculator will start the parentheses for you when you hit ln. Just make sure you close them. 0.693? Okay, thank you for heads nodding. It's nice to have a calculator, but the other like kind of bad side of that is if you hit one button wrong, that it's wrong. So that's why I say practice typing it in. All right, number 8, we'll do this last one, then we'll take a break before we do the other side. See how that looks like a complete mess? Here's the last method we're gonna go over. You can use what's called U-Substitution. I don't know who decided it was gonna be the letter U. It's actually officially called U-Substitution. Like U is the letter that you use. Frankly, I don't care what letter you use, but that's officially what it is. The idea is you take something that looks really complicated and you substitute out the complicated part to make it look a whole lot simpler. It's like, hey, this looks like a disaster, so let's make it look better. So looking at this one, we're gonna let U equal 6 to the x power. Hey, Ms. Cole, how do you know? Well, it just comes from practice. This is another one of those totally crap answers. You kind of just have to look at what's in the problem and substitute out the really yucky part of it, okay? So when we go to substitute in, This first part is going to be u squared. I'm sorry, was there a question? No, okay. It's going to be u squared. That's because 6 squared is 36. Did you guys follow me on that? 6 squared is 36. That'll be u squared minus 7u equals negative 10. And again, the whole point is we took something that looked really awful and we made it look at least a little bit better. So ignore all of this. How would you handle that? We did one kind of similar back in problem 2. Yeah, good. Add over the 10. And then we're going to factor. So see, it made the problem easier to do. You substituted out the really gross part. So that will split u times u. 10 will be 2 times 5. And then what symbols? Both are negative. Good. So we get u equals 2 and u equals 5. Here's the only kind of bad thing. We're not bad, but just we're not done yet. That's u, and we're looking for x. So look back. What did we let u equal in the problem? Yeah, 6 to the x power. So what we get is 6 to the x equals 2 and 6 to the x equals 5. All right, now what? We still want x by itself. So what do we do to both sides? Louder? Log base 6, good. So what you're going to type in your calculator is log base 6 of 2. That'll give you this one. And then log base 6 of 5, that'll give you this one. So log base 6 of 2, that will give you that one. And then log base 6 of 5 will give you the other one. All right, so on this side, we have the logarithmic equations. Now for exponential, remember when we did the graphs, exponential, the domain was all reals. For logarithms, the domain is not all real. So you have to be a little bit more careful with checking these ones. So just write yourself a note. I think we've put this on every piece of paper since I taught what a logarithm is. You cannot log a negative number. Your answer can be negative, but if you plug it back in and you're logging a negative number, then you have to get rid of it. So just make sure that you check these. You don't have to really worry about checking the exponential ones, but these ones you're going to have to check. So here's kind of your methods for these. The first one, use the log properties that I taught you last time. Okay, the last time that we were actually together and I taught a class. Those log properties, when you add the logarithms, you multiply what's inside. Remember adding, multiply? When you're subtracting the logarithms, you're going to divide what's inside of them, all right? Adding, multiply, subtracting, divide. And then the other thing you want to do is write them in exponential form. And that's that thing where it's like when you get stuck, and notice I said when you get stuck, it's not like an if. Like, I'm not going to get stuck, Miss Cole, I'm a genius. Yeah, you might be, but you'll still get stuck. What's the question to get you unstuck? What is the base? Just think, what's the base? And that will get you unstuck, right? These are a lot of times easier than the exponential ones. We'll see how it goes. So look at number 9. What's the base? 2. It's 2 to the power -1 equals x. So all you really have to answer is, what is 2 to the -1? 1/2, good, it's gonna flip it. So x is 1/2. That's not bad, right? Like I said, these are some, like, except for remembering those properties, sometimes people forget those properties, but otherwise these aren't too bad. Look at number 10, what is the base? 7 to the what power? 2, good, 7 squared equals x minus 2. So what is 7 squared? 49. And then add over the 2, you get 51. All right, number 11. Do you notice how this is log base 5 and this is log base 5? Do you see how they're the same? That's good, because otherwise it would be an undoable problem, and I'm not going to give you an undoable problem, right? The only thing that's kind of throwing a wrench in this one is you see that 2 that's out front? So you have to use that log property that says you're allowed to take that 2 and put it back as the exponent. You guys remember that one? Like take that out front, put it back as the exponent. Power to power means you multiply. So we get log base 5 of x plus 2 squared equals log base 5 of 9. And then the log base 5s are going to drop out of there. It's the same on both sides, so those are gone. You've just got x plus 2 squared equals 9. And that's the part that we're going to continue forward and solve. So how do you get rid of a squared, guys? Square root. When you put the square root, you have to also put plus and minus. So it will be plus and minus 3. So you're going to have x plus 2 equals 3, x plus 2 equals negative 3. And then subtract the 2. So this first one will give you 1, and this one will give you negative 5. We're going to keep the 1 and get rid of the negative 5. Again, it's not because that's negative. You can sometimes end up with a negative answer, and it's okay. The problem is when you take the negative 5 and plug it back in right here, negative 5 plus 2 would be negative 3, and you can't log a negative. So you have to get rid of that. So just make sure you're checking them as well. All right, look at this one. Do you see how the logs are being added? Oh, and they both just say log. What does that mean the base is? 10. All right, do you see how they're being added all together there? That means you're going to multiply the stuff that's inside. Adding means you multiply. So we're going to multiply that stuff that's inside. We're condensing it. So write log, put a nice big blank. We're going to multiply these together. It's FOIL. First, outside, inside, last. We're going to multiply those together. X times x, x squared. Good. The outsides give you minus 1x. The insides give you plus 2x. So minus 1x plus 2x would good, just be x. And then 2 times negative 1 gives you negative 2. Again, adding, that means you multiply what's inside. Now I'm stuck. What's the base? You guys already told me, but say it again. What is the base for this one? 10 to the what power? 1. It's 10 to the first, so you don't really need to write that 1 if you don't want to, but 10 to the first equals all the rest of that. And because there's a squared, how will we handle that? We've done a couple of these already today. What are we going to do? Yeah, move the 10 over. Evacuate. Subtract the 10 over so that it all equals 0. So if you subtract 10, that'll give you minus 12 at the end there. And then we're going to factor it. So how is 12 going to split for this one? Good. 3 and 4. And what symbols do we need to get a plus x in the middle? Good. Perfect. So when you set those equal to 0, you're going to get 3 and you're going to get negative 4. Do we keep them both? Get rid of them both? If we got rid of them both, it would be no solution. Keep one, get rid of the other. What do you guys think? Can we keep the 3? Yeah, if you plug 3 back into here, you're going to end up with positive results, but negative 4, if you plug that back in, it will not work. You have to get rid of it. If you're like, hey, Miss Cole, I didn't quite get that. That was a hard problem. I've got you. Let's try another one. Do you see how there's a plus sign right there? That means you're going to multiply the stuff that's inside. I usually circle them. That's what we're multiplying together, the x and the x minus 5. So it's going to be log base 6. Draw a blank. And then you're going to multiply the x times the x minus 5. What will that give us? Perfect. You're just distributing the x. So x squared minus 5x and then equals 2. I'm stuck. What is the base? 6. It is 6 to the second power, good, equals x squared minus 5x. I'm running out of space, so I'm just going to erase and fix it. 6 squared is 36. And then what do we do with the 36? Subtract it over. And then we're going to factor that. So it'll be x and x. And then we need to split up 36. How's that going to split? Yeah, 9 times 4. We'll need -9, +4. Good. So we get 9 and we get -4. We're going to keep the 9, get rid of the -4. If you plug the -4 back in, you're going to get a log of a negative number. And you can't do that. You guys hanging in there? You have to practice it. You're like making us do all these problems. You have to practice a bunch of them to get the hang of it. All right, for this one, what would you do to both sides first? Trying to get x alone. Subtract 4. And then you're probably like, I'm stuck, which is fine. What is the base? E, good. Oh, we haven't talked about it in a minute. What is E approximately? About 2.7, perfect, right? It would be e to the power -4 equals 2x. And now this is kind of like ones we did on the other side of the paper. Getting x by itself, we will divide by 2. So this is what you're going to put in your calculator. E to the -4th divided by 2. Do you remember where the E button is? Well, actually, there's not a button that says E. It's your LN button. Do you guys see the LN button, how there's E right above it? Do you remember when we did the PERT formula? You guys have all checked out on me. How do I get this on the calculator? What am I going to type? Good, second ln. That puts E on your screen. So what was it, E to the -4? So E to the -4 and then divide that by 2. I got 0.009. Okay, thank you for heads nodding. I appreciate it. We just have a couple more here. Do you see how this is adding? You see that big plus sign there, guys? What does that mean we're going to do? Multiply. Circle the parts you're multiplying. I think that helps. You're going to multiply the 2x plus 1 times the x. So it'll be ln, leave a blank. When you distribute that x through there, that's going to give you 2x squared plus x. What is the base? E to the what power? 0 equals all the rest of that. And again, I'm running out of space, so I'm just going to erase it. What's e to the 0? 1. Anything to the 0 power is 1. Subtract over the 1, and then we're going to factor it. So this one's not just x and x. This one will be 2x and 1x. And then 1 is 1 and 1. We want a positive x in the middle. So we would need plus 2x. So I'm going to need plus with the outsides there, and then minus 1x for the inside. So set those equal to 0. You would get, well, let me ask you, what would we get from this first one? 1/2, good. And then -1, good. Keep them both, get rid of one of them. What do you think? Yeah, we can keep this one, perfect. All right, so look at number 16. Do you see that subtraction sign? For all the adding ones, we multiplied. So if it says subtracting, what does that mean we're gonna do? Means you're going to divide. I still like to circle what's inside of there. I think that helps. If not, I mean, bless you. If not, you don't have to, obviously, but we're going to divide the parts that I circled, right? Subtraction means we're going to divide. So do ln, leave a big blank. Inside of there, we're going to divide those. So it'll be x plus 3 over x. And then we'll have equals 4. As a heads up, that's going to make the problem slightly more complicated because now you have a fraction. Again, I believe in you and you're going to be okay, right? But I'm stuck. What is the base? E. It'll be e to the what? Good. E to the 4th equals x plus 3 over x. Now, what you have to remember as we go through the rest of these steps, e to the fourth is a value. That's just a number, okay? To get rid of this fraction, we're going to multiply over the x. So multiply over the x. You will have x times e to the fourth, which is a number, equals x plus 3. Now we're kind of stuck because we have two x's and they're on different sides of the equal sign. So I need to start off by getting those together. I'm going to come over here. Subtract over this x so that at least both of your x's are on the same side. So I subtracted this x to the other side. They're not like terms, so you can't put them together, but at least now all the x's are on one side. And then you can factor it out. It's GCF, right? When you factor out x, what's left? Good, e to the fourth minus, there is something there, and I know it's a little tricky. Perfect, minus 1. And then to get x alone, you'll just divide that to the other side. So it's 3 divided by e to the fourth minus 1. And that's what you're going to put in the calculator. So you're going to type in 3 divided by e to the fourth minus 1. If you want that fancy fraction bar, do you guys remember how to do that? Does anyone remember how to get that fancy fraction bar on your calculator? It's been so long since you've had a calculator. Does anyone remember? It is alpha y equals. That'll be your best friend for getting those fractions on there. Alpha y equals. N over d means numerator over denominator. It'll put that fraction on there. Alpha y. Write that down in the margin of your paper. Alpha y equals. You're going to want to remember that because it makes life easy with typing this in. And then you're going to do 3 over e to the fourth minus 1. And remember, e is second ln. Now you go so long without using a calculator, and now I'm like expecting you to know where all these buttons are. That's why I'm going over it again and again. You got to practice it. All right, 3 over e to the fourth minus 1. We'll see who's brave, if anyone wants to share. What'd you get? Oh, me too. Just take the first 3 decimal points. And I do realize that's weird too. I know like every teacher asks you to round differently. I don't have a way around that. I know like in science you do significant figures or whatever. Like in here I'm telling you to do 3 decimal points. I get it. So I'm sorry. I'll try to remember to remind you a lot. All right, last one. We're going to do a word problem. In 1990, the world population was 5.3 billion people. The estimated rate of population growth is 1.6% per year. Here's the equation that models it. Does that look like PERT to you? Because it is, okay? T is the number of years since 1990. P is the population in billions of people. All right, letter A. What is going to be the predicted world population in 2022? You're not going to plug in 2022 because what time did we start at? 1990. So you have to do 2022 minus 1990. How many years went by? 32. And that's what you're going to plug in. So what you're going to do is pick up your calculator and type in this equation, except plug in a 32 for t. So 5.3 e, which is second ln, 0.016 times 32. Plug a 32 in for the t, and that's going to be the predicted world population this year. I don't know offhand exactly what the world population is right now. Does anybody know it? I'm gonna Google it really fast. Anyone want to share what you got for this? What our predicted world population is this year? 8.843. Okay, so this estimation is off. All right. That's 8.843 billion people. Good. You always have to put units if it's a word problem. So what did they say? It actually is 7.9? Oh yeah, I guess that's true. But I don't know that we're going to gain that many people in 12 months, not 11 months. I don't know. How many people can the world support? All right, letter B. when, so this time we're looking for t, we don't have the time, when will the world population reach 10 billion people? So what you're going to do is take this equation and set it equal to 10, and we're going to solve it for time. I realize that there are some decimals in there. Number one, you're going to be okay. And number two, you have a calculator. And number three, you're going to be okay. All right. Everyone panics because of the decimals. All right. First thing, how do we move over the 5.3? Divide. Here's my suggestion with that. Just write 10 over 5.3. If you write 10 divided by 5.3 in your calculator, you're going to get a decimal. So you might as well just leave it like that anyway. It's just not worth it. All right, and then now what do we do to both sides? I want to cancel out e. How do you cancel out e? ln. We're going to ln both sides to get those to cancel out. So you will have 0.016t equals ln of all the rest of that. I would put some parentheses around that. Give that a hug. The 10 over 5.3. And then what's the last step? Get t by itself. Divide by 0.016. All right, so this is what you're going to type in the calculator. Have fun. Don't just stare at me. You have to practice doing it. Type this into your calculator. Time. Now, I know we've done 3 decimal points, but let's round to the nearest whole year. Go ahead. Almost 10 billion, and we're at 7.9. Ugh. We're getting there. Oh, wait, you said the Earth can support 10 billion? Almost 10. Oh, well, we set this equal to 10. So let's see how many years we've got left to live, guys. What did you get when you typed this in? Divide 0.016. Yeah, I got 39.679. Is that what you got? Okay, well, let's say 40 years. Now, that's not the answer to the question. It says when. Remember, this is years since what year? 1990. So you have to take 1990 plus 40 years. It would be in the year what? 1990 plus 40 years. 2030. That's the year my son will graduate high school.